Linear variable differential transducer or LVDT. This is also known as a linearly variable differential transformer, so because it is working on inductive principle. So it is a very basic transducer which always useful in the field of instrumentation. Its principle is that it working under mutual induction, and the displacement, which is a non-electrical quantity, is converted into electrical energy. In construction, it consists of a cylindrical former as shown in this picture, where it is surrounded by one primary winding in the center of the former and two secondary windings. These two are the secondary windings at the sides. And at the center, there is a core. The core is generally made of high permeability nickel iron, and this core can slide in this horizontal axis to and fro. It can go inside the cylindrical former, or otherwise it can come out of the cylindrical former. The number of turns, because we know that we have got two secondary windings, so that is S1 and S2, and the number of turns in both the S1 and S2 are same, but they are opposite to each other. In the sense, for example, if the left secondary winding is on the clockwise or left or the top, in this picture it is top, is clockwise direction, then the right secondary winding or the bottom, here it is bottom, will be in anti-clockwise direction, such that the net output voltage will be the difference in voltages, because the voltage induced in S1 and S2 will be opposite in nature. The direction will be opposite in nature. So the difference in voltages between the two secondary windings will be our net voltage output. The working of LVDT can be explained by three cases. In the first case, we are considering the null position of the core. That means the core is at exactly in the middle portion between the two secondary windings, the S1 and S2. That means in this picture we can see that the fluxes cut by both S1 and S2 are same. That means the voltage induced on S1 and S2 are same. So the net output will be V1 minus V2, and that is equal to 0. That means the output is 0. There is no change in our output, and that's why it is known as null position. The second case, the core has moved left hand side of the cylindrical former, so it is moved like this. So that means in this picture we can see that more flux is in contact with the secondary S1 compared to S2. Here the less fluxes are actually interacting with the coil S2. That means the V1, that is the voltage induced on X1, that is the V1 will be greater than V2. So the output will be V1 minus V2. That will be our output, and this will be a positive quantity since V1 is higher than V2. The third case, the core moves to the right direction, that is right hand side direction. That means the core has have a movement in this direction. This picture is not correct because we have to redraw this as the core is moving like this. Okay, now in this picture we know that the fluxes are more interaction of fluxes is happening at S2 compared to S1. That means V2 is greater than V1, or otherwise the difference V1 minus V2 will be a negative quantity. Thus, using an LVDT, we can have a change in change in output voltage with respect to the position of the core, and this core is actually measuring some displacement. So the displacement physical quantity is converted into an electrical signal. That's why it is a transducer. The characteristics of LVDT can be plotted into a curve like this, and we can plot in two ways. In the first, it is a phase referred output voltage of LVDT, and here the horizontal, that is the x-axis, is representing the core position, that is it is representing the displacement, and in the y-axis we are plotting the voltage output. So if we consider the positive voltages and negative voltages, the curve will be like this. A linear characteristics is obtained, and it can, if we consider the absolute value of output voltage, that is we are not considering the symbol, then it will be, if it is plotted in the same manner, that is in x-axis it is the displacement and y-axis it is the output voltage, then we will have a shape of inverted cone. In application of LVDT, it can be used for measure the displacement ranging from fraction millimeter to centimeters. It is also taken as a used as a secondary transducer for measurement of force, weight, pressure, etc. Thanks for watching.